Hi friends, welcome back. So in this part we are going to study about the questions based on the things which we have learned in the previous part. So I guess now all of you must have learned the formulas which were given to you by me in the previous lecture. So today we are going to apply those formulas, those concepts in the questions. Let's begin with the part. Let's start with the first question. Okay, so find the derivative of x to the power 5 by 2. Okay, so again, if by now if you must have been remembering that formula, x raised to power n, and the derivative of that is nx raised to power n minus 1. So from this straight away we can write 5 by 2 x and minus 1 will give me 3 by 2. Okay, now again going to the literal meaning. Okay, here now x raised to power 5 by 2 is the function we are looking at, and if I want to know that if I change x from suppose 1 to some value, okay, so for that the measurement of the change which will come in this corresponding to this will be given by this function. Okay, so the rate of change of this with respect to that at this point will be given by this function. If you want to know suppose at 2, so you will first find the derivative of this function, put the value 2 in that, and that will give you the rate of change. If you change a bit from this point, then how this value is going to be changed, that rate it will give. Okay, going by the first principle again, as I mentioned that I will be doing both of them. So we will first write x plus h. Okay, so f of x plus h, sorry, so this will be x plus h raised to power 5 by 2 and minus f of x, that will again be minus x raised to power 5 by 2 divided by h. Okay, in most of the cases our aim will be to remove this thing, basically h part. Okay, so in this part again it looks a bit complex, but what we can do again, this is raised to power half kind of thing, we can again factorize this thing. Okay, x plus h raised to power 5 by 2 minus this will give me plus, sorry, x by 2, denominator we are gonna keep it as it is, because when we are gonna substitute h is equal to 0, this will be x raised to power 5 by 2, this will also be x raised to power 5 by 2. Now once we do rationalization, what will happen here? X plus h raised to power 5 minus x raised to power 5. Now clearly if you expand this using binomial, okay, so the first term will be x raised to power 5, other will be having x raised to power 4h, again with the coefficients. Okay, I'm writing it here. Okay, so using some other color now. Yeah, so this one x cube h square, it will go till h raised to power 5. Now what is our concern? That we want to cancel h. So in all the terms except this, there is one x. Okay, so minus x raised to power, if I do, this will get cancelled, and the only term which I will be left is this one. Why? Because the other one will have, all the terms will have 1h, and that will make it 0. So I only need to get this one. So coefficient of that one, obviously you can do from here, 5c0 will be this, this is 5c1. Okay, so 5c1 will be the coefficient. Okay, so this you will get with x raised to power 4, okay, h, and this will get cancelled with the this h. Rest other will become 0. Okay, once we put h, so we don't need to worry for that, and denominator this will get cancelled, and what we have to do after this is this one, handle this one, x plus h here raised to power 5 by 2 plus x plus 5 by 2. Now once you put h is equal to 0, now it's very simple. Okay, so this way from here you will be easily directed here. Okay, so this is how the first derivative explains everything. Okay, that how this formula or how this final result is obtained. So we have made rules for different kind of functions. This was again algebraic function. For exponential it remains same. Okay, so if I talk about e raised to power x or ln x, it remains same. In this part it becomes 1 by x. So all these results, they are obtained from this principle. Okay, so we don't need to do the principle every time, we can remember the results and go for the differentiation. Let us look at one more example to make the things more clear. Okay, find the derivative of 1 plus x raised to power half. Again, very same way. Okay, so if I go in this manner, okay, 1 plus x raised to power half. Okay, so again in this, some of you will say, okay, how will I, you gave us the formula for x raised to power n, but what happens when 1 plus x raised to power n, kind of that. Okay, so that will again follow the same rule unless or until there is a variable. Why? We'll cater this when we will learn more techniques. Okay, but for here you can trust me for now that okay, we are going to do like this. Okay, so this will again be going to the same formula, x plus 1 raised to power half minus 1, that will be minus. So this is by direct using this formula, x raised to power n. Okay, now this is a constant here, so this won't be mattering. Okay, otherwise if it would have been suppose x square, x cube or something of power x, then we would have gone for a bit different strategy. Okay, so we will learn that strategy in the coming parts. Okay, by first principle again, now I don't think that it's required, but still I'll do because it will make it more clear to those who are still not able to get the concept. So this is what our first principle says. Okay, so x plus h will give me 1 plus x plus h raised to power half minus 1 plus x raised to power half. Okay, divided by h. Now again in this, what we are seeing that whenever we are doing it, rationalizing the numerator, so one term will open up like this and maybe some power, maybe some power, but in this case it's very simple. Again it will become squared, so minus 1 plus x. So this term gets cancelled with the this, and the remaining h part, it gets cancelled with the this part. Okay, so that is what our aim is, that we need to remove this thing, and this you all of you must have studied in the limits, that for in limits we can do this. And again L hospital rule we'll also discuss, you must have done that, but we will also do in the miscellaneous part that how to find the derivative or limits using that rule. Okay, so same thing will go here again, and you will be left with here 1 plus x plus this raised to power half plus 1 plus. Now whenever the question plus comes, okay, then obviously whenever you will put 0 or whatever the values of h, the discrepancy gets over due to plus. Otherwise what happens if you put minus, this will again get cancelled. If the power is, suppose here it is half, but suppose it's not half, then it gets cancelled. Okay, so we don't want that. In plus it gets added, so case of 0 gets eliminated. Okay, so I guess these two questions must have clarified what we have learned in the previous part, and again we will be discussing much more interesting which lies ahead of this part. Okay, this is just starting. Okay, it might appearing a bit boring at this point of time, but as we will learn new rules, we will see that how the things there, what differentiation we started with, like geometrical meaning, and what we end up, okay, that becomes very different. Okay, in terms of understanding part, although that is equivalent to what we will learn, but in your mind what you started with, okay, differentiation is something like slope. Okay, but when you are going to follow that thing, then you will see that okay, we are just more relied on the formulas. Okay, and logics I'll give definitely. Okay, so two questions for this part, that's it. I hope the questions which I have discussed, they were not that difficult, but yeah, the concepts which we have learned, you must have got a clear idea of what lies ahead. Okay, obviously this is beginning, and for those who are doing it for the first time, this is the perfect way to start. Do some questions here. Once after this video, do some questions by your own, or maybe some reference books which you have, and you must be having clear idea, okay, in whatever things you're going to do. In next parts we are going to start about new things. Okay, stay tuned for the next part.